You know, in one of our videos on YouTube, I said atoms can be classified one based on their nature. They could be metal, metalloid, non-metal. They could be classified based on the orbits, the orbit that contains their last electron into S block metal elements or atoms, P block, Z block, and F block. I gave about 3 ways of classifying this. The F block, remember, are those that are outside the main periodic table. They're just below the actinide and the lanthanide. The D block are those ones that are between group 2 and group 3 transition metal. The S block, then the P block. But we are looking at electronic configuration using the SPDF orbital. The last one we did was using the KLMN shell, which is actually not the right way of writing electronic configuration. The right way of writing electronic configuration is this. The reason is this: if you have to use the KLMN shell to write electronic configuration for transition metals, you will have an issue. You will definitely have an issue. Let's take, for instance, a transition metal has atomic number 27. It's going to be 2, 8, 8, 8. This is 10, 18. 18 plus this, 26. Remaining 1. This is what you are going to have. You are going to have 1, 2, 3, 4, 5. Pay attention. Period 5. What's the group? Group 1. Please. Transition metal. I told you they are found between what? Group 2 and group 3. You see that error? So this is not, the KMNL is not actually the right way of writing electronic configuration. It's wrong. Number 1, look at the number 1 error. The maximum number of electrons M can take is 18. M can take is 32. But in your class, what did they say? 8, 8, 8, 8. So it becomes a problem. It becomes a problem. So please take note of this. So we need to understand the SPDF electronic configuration. Right. The SPDF orbits have different energy levels. The S orbit has the least energy, followed by P orbit and D orbit, and the F orbit has the highest energy level. And the F orbit has the highest energy level. As a rule of thumb, a general principle, the orbit with the lowest energy level is first filled up with electrons. The orbit with the lowest energy level is first filled up with electrons, then to the next, to the next, and to the next. That's S is first filled up this way. So S is S less than P less than G less than F. So that's our speed up. So these are different energy levels. Also, each of these orbits have some energy levels. So, like the S orbit has 1s, 2s, 3s, 4s, etc. These are some energy levels. So, So we first fill up this 1s before 2s, then 3s and 4s. We first fill up s before p before d before f. The maximum number of electrons the s orbit can take is 2. The p orbit can take 6 electrons maximum. The d orbit can take 10 electrons maximum, and the f orbit can take 14 electrons maximum. 14 electrons maximum. Now, there's a way these things were arranged for you, and it gives you problem like this: 1s, 2s, 3s, 4s, 5s, 6s, 2p, 3p, 4p, 5p, and there's 7, 6p, 3d, 4d, 5d, 4f. Did you see what I just did? Did you notice what I did? What I did? What I did? I did 1s, 2s, 3s, 4s, 5s, 6x, 7x. When I started with p, I started from the next one. 2p, 3p, 4p, 5p, 6p. I did not end it. When I started for d, I started the 10. 3d, 4d, 5d. When I came to f, I started at 5f. 4f. 4f. So I have 5f. 5f. And they said you go this way. Is that not? You go this way. That after 1s is 2s. After 2s is 2p, 3s. So what's what I will do? I put this arrow like this, but I put this arrow like this. I joined it. So I went from 1s to 2s. From 2s I went to 2p, 3p. After 3p, 4p, 4s to 3d. And this is how it goes. However, pay attention. This confuses students. Therefore, I'm going to make it simpler for you. Just know that S is the only one that has 1. Then it has 2s. After 2s is 2p. After 2p is you go to 3s. You start again. 3s, 3p. Then before you go to 3d. Then I go to 4s, 4p, 4d, then 4f. S1, S and P 2, SP and D 3, SPD and F 4. However, there's an issue here. This is the right way it should have been, but 4s has a lower energy level than 3d. So 4s is first filled up before you fill 3d. Hence, we now readjusted this to be 1s, 2s, 2p, 3s, 3p. So right 3d, we now jump 4s, then 3d, then 4p, 4d, 4f. This is an aberration. Look at it. Look at 4, then 3. Look at it. It ought to be 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Look at it. 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. But now we've adjusted here. Please write this now. Write what you have on board. So I said, right, the 3D is usually written or usually filled first before the 4s. That's why we have this order The 3D is filled first before the 4s. This is why transition metals have partially filled d orbital. This is why transition metals have partially filled d orbital. What is the why? Instead of filling the 3D, you leave the 3D, you first fill up the 4s before filling the 3D. So the 3D is usually not complete. And that's a huge property or characteristic of transition metals. Now let's really look at the table now. So let's set. Look up please. So we have what to do. We have atomic number. We have electronic configuration. Now we have, just like we did before, we have the group, we have the period. Please pay attention. We have the valency, and we have the nature. But of course, we know the rest. I will stop at this 4 columns. I will not start with 1. I will start with 6, 7, 8, 9, 10, 11, 12, 13, 14. Remember, the S can take 2. When you fill the first 1S, you go to the next level, 2S. When it's filled up 2, you go to the next level, 2P, that's 6. Once it's filled up, before you go to the next level, 3S, then 3P, 3D. Don't get these things confused. S is the first one, 1S is the first one. So only S has 1. S and P. What is this? How many? 2. So you must use 2 things, S and P. What is this? Well, 3. You must use 3 orbits, S, P, and 4, S, P. So 1, only the first one, S, has 1. 1S. 2, the first 2, S and P, have 2. 3, S, P, D, have 3. 4, S, P, D, F. So you cannot see 1 F. Can you see 1 F? Can you see 1 P? Please take note. That's why how I want you to memorize this thing. So let's go. This is 6 electrons. So 1S is the first one, let's power 2. Remaining 4. 2S is the next one. You can take away how many? 2. I mean, remaining 2. So 2P is the next one. Remaining 2. I'm not going to send it here. Let's go. 1S raised to power 2. Remaining 5. 2S raised to power 2. Remaining 3. 2P raised to power 3. Next one. 1S raised to power. Okay, let me jump. Come here. 1S raised to power 2. Remaining 8. 2S raised to power 2. Remaining 6. 2P raised to power 6. 1S raised to power 2. Remaining 9. 2S raised to power 2. Remaining 7. 2P raised to power 6. Remaining 1. 3S raised to power 1. I'll do and stop here. 1S raised to power 2. Remaining 10. 2S raised to power 2. Remaining 8. 2P raised to power 6. Remaining 2. 3S raised to power 2. Now let's look at this. Pick up your pen now. The number of electrons on the outermost orbit, the number of electrons on the outermost orbit gives the group. Gives the group. Look at it. Do you see what's the outermost orbit here? How many electrons do we have here? 1. So we group 1. How many electrons do we have here? Group 2. Stop. However, when the last 2 orbits have the same sub-energy levels, The group is the sum of their electrons. The group is the sum of their electrons. Look up. Example. Look up. The group here would have been 2. But watch it. This is 2. This is 2. So you add them. The group is 4. This is sub-energy 2. Sub-energy level 2. So you add them. The group is 5. This is sub-energy 2. Sub-energy 2. So you add 8 at it. And don't always say the group is 0 completely. Don't forget your KMLS. You can write 8 because I went out to see one of my students. It was 8 she wrote there. In fact, she wrote 9 in traditional method. No, I will not tell you this so that you make the same mistake and I correct you. Now the period. That's right. The sub-energy level of the last orbit gives the period. The sub-energy level of the last orbit gives the period. Gives the period. So look up. Look up this. I want to stop. The sub-energy level of this last is 2. Period 2. Of this last is 2. Of this last is 2. Of this last is 3. Of this last is 3. So this is how electronic configuration is written using the SPDF orbit. I hope you've enjoyed the class. We'll see you again in next class.